Hello everyone. We have all learned about metals and non-metals and their properties in our junior classes. Today in this video we are going to learn about the most important property of metal and non-metal, that is reaction with each other. To understand this, let us take some examples of metals and non-metals. And by the end of this video, you will understand how metal and non-metal react with each other and what type of compound is formed between them. So, to understand this, let us take first and discuss about nature of metals. Sodium, magnesium, calcium, aluminium are few examples of metals. If we look at the electronic configuration of these metals, atomic number of these metals are 11. Sodium is 11. So from this, we write the electronic configuration as 281. Magnesium is 12, and we write the electronic configuration of magnesium as 282. Similarly, calcium is 20, and hence its electronic configuration is 2882. Aluminium is 13, its electronic configuration is 283. So, metals, if we see from few of these examples, metals have valence shell with 1, 2, or 3 electrons. And to become stable, we all know, we have learned about octet rule, that for an atom to become stable, either the last shell should be fully occupied or it should be vacant. So if this sodium metal try to be stable, either here the last shell, this is our last shell, it should have either 8 electrons or 0 electrons. What will be easy for this sodium? It will be to lose electrons, because gaining 7 will be difficult. Similarly, magnesium has 2 electrons. Gaining 6 electrons will be difficult, and losing 2 will be easy. Similarly, for calcium, it will be easy for it to lose electron. Aluminium, it will be easy to lose electron rather than to gain 5 electrons. So metals have a tendency to lose electrons. Similarly, non-metals, if we discuss, some examples of non-metals are chlorine, oxygen, sulfur. And if I write the electronic configuration of these, this is 287, this is 26, this is 286. If we look at the electronic configuration of these, last shell has 6, 7, or if I take some other element, it may have 5 electrons also. So for this to become stable, losing 7, losing 6 or losing 5 is difficult. Rather, if it gains 1 electron, it becomes 288. That means fully occupied. The last shell is fully occupied. If this gains 2 electrons, it becomes 28, again fully occupied. If this gains 2 electrons, it becomes 288. Again, it attains stability. So non-metals feel comfortable in gaining electrons. So that means they can help each other. Why they can help? Because metal wants to give and non-metal wants to accept electrons. So there can be a compound formed between them by transfer of electrons. To explain this, how the bond is formed, how the electron transfer takes place, there were symbols given by Lewis. He said to represent this, each element can be represented by a symbol. and the symbol, because it was given by Lewis, these symbols were called Lewis symbols. He said that each element, whether you take chlorine, sodium, magnesium, calcium, I can represent the valence electron present in the atom with the help of dots or cross. So for example, if chlorine is 287, I can draw 7 dots around it to show that this chlorine atom has how many valence electron? 7. Sodium is 281. I can draw 1 electron to represent, or 1 cross. Any one you can use. Either you use a cross or you use a dot to represent the Lewis symbol. Similarly, magnesium is 282. I can use 2 crosses to represent magnesium atom. Calcium has 2882. We use 2 cross or 2 dots to represent the calcium atom. Okay. So these Lewis symbols were used to explain the formation of compound between metal and non-metal. Now let us take an example of formation of a compound between sodium and magnesium. Sodium we all know is a metal, and magnesium chlorine we all know it's a non-metal. So if I write the configuration of sodium metal, it is 281. So sodium has 1 electron in its valence shell. Chlorine on other hand is 287. So if I draw chlorine atom, represent it, I will make 7 dots to represent chlorine atom. Now what will sodium do to become stable? It has to lose this electron. And what will chlorine do? It has to gain 1 electron. That means if sodium wants to become stable, it will lose 1 electron and become a positive ion. Why a positive ion? Because atomic number of sodium is 11. Protons are also 11. Electrons are also 11. So here we have 0 charge. But when it loses electron, protons remain 11, but electrons become 10. So it becomes a positive ion. So sodium, what will it do with this electron? It will give away the electron. On the other hand, chlorine has configuration of 287. It has 0 charge, but to become stable, if it gains 1 electron, it becomes Cl negative, that is 288. So what will chlorine do? Chlorine has gained 1 electron and 1 electron it needed. So that means the lost electron by sodium can be taken by chlorine to become stable. When Na loses its electron, it becomes plus. When chlorine gains 1 electron, I am representing the electron taken by sodium by a cross, just to make you understand that this electron was being given by sodium atom. It becomes negative. And there is a force. There is a force between, because they are charged species now. Sodium formed a positive ion. Chlorine formed a negative ion. This is a negative ion. So there is a force between them which holds them together. Such type of a force is called electrostatic force of attraction. And such a compound which is formed, because this is electrostatic force will be between which compound, which species? Charged species, because it is electrostatic electrons which attract each other, isn't it? I mean charge species which attract each other. So this type of a bond will be formed between ions. Charge honge because they will be. And the ions will form a compound. This type of a compound between ions which holds them together is called an ionic compound. Okay. So sodium because it wants to donate electrons, and chlorine because it wants to gain electron. They formed a combo with each other and they formed a type of an ionic compound. Let us take one more example. Magnesium and oxygen. Magnesium configuration is 282. Oxygen configuration is 26. When I draw the Lewis symbol, magnesium has 2 electrons. When I draw the Lewis symbol of oxygen, it has 6 electrons. So what will magnesium do to become stable? Magnesium loses 2 electrons. The number of electrons lost will be the charge. If an atom loses 3 electrons, I will make plus 3 charge. If it loses 2 electron, I will write plus 2 charge. Why plus? Because proton increase. Oxygen on other hand needs 2 electron, and when it gains, it becomes O2 negative. So if I try to represent the bond formation between these, this is magnesium, this is oxygen. Oxygen has 6 electrons, magnesium has 2 electrons, and when the bond they come close to each other, magnesium gives its 2 electrons to oxygen and we get Mg2 plus magnesium ion and O minus 2 oxide ion, and we get an ionic compound magnesium oxide. Okay, so the theory which we read in our junior classes, that magnesium has tendency to lose electrons, oxygen has tendency to gain electrons. That means metals lose electron with the help of electronic configuration. We have already learned valence and valence electrons and Lewis symbols. It helps us to explain the formation of an ionic compound. And the force which hold these ions are called electrostatic force of attraction and which makes the atom stable. Okay, so I am giving you one homework. We have read today how an ionic compound is formed, what is an ionic compound, what charge metals will gain, what charge non-metals will gain. Please write Lewis symbols for atoms with atomic number 1 to 10 and try to rewrite the formation of the ionic compound NaCl. I hope you liked the video. Thank you. Have a nice day.